All right, so the last of our shortcuts is HL, which stands for hypotenuse leg. So if we think about those two terms, the hypotenuse and the leg, those two terms are only present if we have a right triangle. So for HL, we're saying that the hypotenuse and one of the legs has to be congruent to the same sides in another. So again, we can only use hypotenuse leg if we have right triangles. Now, that does not necessarily mean that just because you have a right triangle that your answer is HL. We saw an example over here a second ago where those are right triangles, but in this case you didn't know the hypotenuse. You could not have said HL here, okay? But you should never be using HL if you don't see a 90-degree angle. So what we're looking for is the hypotenuse that comes across from the 90-degree angle. Those two have to be congruent. And then either the two longest legs or the shortest legs, as long as you have the matching pair. Okay? All right, so for this one, it says determine whether or not you could use hypotenuse leg congruence to prove that the triangles are the same. If not, what else would we need to know? All right, so if we look at this first set, the first thing I would notice is even though there's not a 90-degree angle drawn here, I know that that angle should be 90 degrees based on the fact that these two together are a linear pair. And if this one's already 90, that one would obviously have to be 90 as well. So we do have two right triangles. The sides that I currently see are congruent would be the two hypotenuse sides because they're the sides across from the 90-degree angle. And then again, even though it's not marked, this side down the middle would be congruent to itself if we were to pull those apart by the reflexive property. So I would say yes, we can use HL here. All right, for this one, I noticed that we do have right triangles kind of built on the side of this square. We do currently know two legs are the same, but we're missing whether or not the two hypotenuses are the same. So no, this is not enough information. We would need to know that the hypotenuse sides are congruent before we could actually say HL. All right, so all of the ones we've talked about so far, we've had side, 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 angle, side, angle, side, angle, 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 side, hypotenuse leg. And remember, we talked about yesterday, side, angle, side is special because that is not the same as also saying angle, side, side. If you ever spell that on a test or even SSA, it's just backwards. That should be a red flag to you that that is a no-no. You have looked at it incorrectly, okay? So I want to talk for a second about why that can never work as a reason for congruency. All right, so I'm going to kind of show you an illustration on GeoGebra and take whatever note or sketch whatever picture helps you remember this because you might have to reiterate this to me on your test, okay? So what I kind of want you to notice here is I have used the tool in GeoGebra that allows me to fix a distance, right? The lines that have to keep a given length. To say that A to C has to be 10, C to D has to be 8, and angle CAD down here at the bottom has to be 50 degrees. All right, but notice that for the purpose of this illustration, this side can be moved, okay? So, for instance, I could give you a triangle, ignore the lines at the bottom, that looks like this, okay? Angle still 50, side length's 10, side length's 8, but that would obviously change the distance of, in this case, A to D would be 8.8. All right, what I could do, though, is I could take this point D and I could almost just kind of move it. All right, so just imagine with me visually. I still have a triangle where the angle's 50, one side's 10, one side's 8, but now obviously A to D is a lot smaller than it was originally, okay? In this case, it's only 4.1. So the reason angle side does not work is because even though those two side lengths are locked in, the angle at the top, you see angle C at the top, is not necessarily locked in, which means really I could have my triangle come out to here, or I could have it come into here. Those two are not congruent triangles, despite the fact that two of the sides and the angle at the beginning did not change size. Okay? All right. The question right beside that says, why can't I just use angle, angle, angle to show that two things are congruent? This kind of plays along with what we talked about last unit with dilations. Anytime you dilate a figure, the measurements of the angle should stay the same. The only thing that changes is how long the sides are. So if I give you a triangle with 3 angles of any given size, all right, if I came in and just made this figure bigger, so let's say I want to dilate that figure. Let's maybe say that I want to dilate it around that point. Let me make those points show back up. All right, so let's take this figure. Let's dilate it, make it twice as large. All right, can you see how I obviously made the side lengths larger, but these angles here did not change size at all? So if I measure from F to E to G, 71 still is 71. If we measure from F to G to E prime, the angle at the bottom was 54.6. Even in my bigger triangle, still 54.6. Okay? So just because the angles are the same size doesn't necessarily lock in that the sides have to be the same length. Therefore, you can end up with triangles that are similar, but they are not congruent. Okay? So take whatever notes. You can go back and pause and rewind the video, whatever, for those two questions to kind of help you understand. Put it in your own words. Okay? All right, based on the information, determine whether or not a congruence exists between the triangles, and if so, write a proof. All right, so let's look at the information we're given. M is the midpoint of HP. So if HP is the segment and M is right smack dab in the middle, then that means that from H to M and from P to M, those two lengths should be the exact same size. Okay? So I would state that first. M is the midpoint of HP. That information was given. Directly from that, I can now say that HM is the same size as PM because by definition, that is what a midpoint does. It splits a segment into two smaller and congruent segments. Remember, just like before, if I'm going to talk about something being a midpoint, my next statement should talk about what happens because of the definition of a midpoint. All right. Thirdly, I can talk about the other information that's given. Angle H and angle P are congruent. So the measure of angle H is the same as the measure of angle P. That was given. All right. Other things that are not necessarily shown, but that I can see from my picture. These two angles in the middle should also be congruent because they're vertical from each other. So angle HMG, make sure you name it with all 3 letters to be specific, is congruent to angle PMR because those angles are vertical. That is now enough to say that the triangles are congruent because I have 3 pieces of information. So triangle HMG is congruent to triangle PMR. In this case, it would be ASH ASA, because the two angles that I have, the side that I have connects both of them. So that would be ASA. All right. For this one, I'm actually going to let you try this one on your own, see what you can do. Notice that you're trying to prove here if ARY, if this triangle is congruent to XRB, this triangle. All right, so think about the stuff that's given, anything else that you could also tie in from things that you should already know, and prove that those two triangles are congruent. Okay, so that'll be it for day 3. Once you get through with these notes, make sure you go through and look at your homework for day 3. You've got 12 questions in all, so make sure you don't forget to flip over to the back and finish that one. On Monday, we will have a quiz over everything we've done so far. So covering all 5 of those types of shortcuts. We'll have a few kind of like on your homework where you have to go through and tell me what additional stuff do we need, what stuff's missing. You will have 1 or 2 proofs, but for the most part, it's going to be kind of just determining, are the triangles congruent? There's also going to be a little bit of stuff like from day 1 where you go through and just identify the parts that are corresponding and writing a congruency statement. All right. We'll have kind of a practice day on Monday, just working through kind of reviewing some of that stuff, and we'll quiz kind of towards the end. But just make sure that you're prepared to come in and do your practice day, prepare for the quiz at the end, and don't forget to do your homework. And hope you all have a great weekend, and I will see you on Monday.